So we're on page 3 now, and we're still talking about the idea of molar mass. We were getting our molar masses for an element off of the periodic table. But we can go a step further, something that's very helpful in this class. So because we know the molar mass of each individual element, we can calculate the molar mass of a compound. So here's what we know. We know a chemical compound's formula, and we know how much 1 mole of each atom has in mass. We can figure out the mass of the compound. So to do this, we multiply the molar mass of each element by its subscript in the chemical formula. Then we add the total mass of each element to find the molar mass of the entire compound. Now here's the way I generally teach it, and this works really well. This is kind of like training wheels. Once you get the hang of it, we're going to get rid of the training wheels and you'll just do it faster ways. But here's how it works for now. So let's say that we want to know what is the molar mass of water. So we know a few things about water. Just looking at its chemical formula, we know that there are 2 hydrogens. We know that there's 1 oxygen. Looking at my periodic table, I know the mass of hydrogen, and I know the mass of oxygen. So from here, it's just a matter of putting the numbers together, and then we'll have the mass of this water. So here's what I do. So this learner's method, I make a table. So here's the chemical formula. This is the first column. Then I write molar mass. There's my second column. Then I write Qn for quantity. And then I have a column that is total. So in the first column, the one that has the chemical formula, the only thing I'm going to do is write out the elements that I have in this compound. For this one, it's hydrogen and it's oxygen. For molar mass, I look at my periodic table. So looking at hydrogen, I'm going to round it to 3 significant figures. And so it's 1.01, and the units are grams per mole. For quantity, I'm looking at the chemical formula. This 2 right here tells me that there are 2 hydrogen atoms in a molecule. And then last, we're finding the total mass of all the hydrogens in this formula. So 1.01 times 2, 2.02 grams per mole. Just so we know what we did here, this is a multiply, this is the equals. That's how we found the total mass of the hydrogens. We're going to do the same operations for oxygen. So I know that oxygen, look at my periodic table, it's going to round to 16.0 grams per mole. Looking at the formula, oxygen has no subscript, which means that its its subscript is 1, which means that for every water, there's 1 oxygen. And so 16.0 times 1, and that is 16.0, and that's grams per mole. The last thing we do is add the total mass of each element. So we're going to total these up. So 2.02 plus 16.0, that is 18 point, it would be 02. But remember our rules for significant figures. When you're adding or subtracting, the number with the fewest digits after the decimal determines the answer. So oxygen had one digit after the decimal. That means our answer only has one digit after the decimal. 18.0, and the units are grams per mole. And this is the molar mass of water. So how about this one, CH4. So let's set up our table first. CH4, we have carbon, we have hydrogen, molar masses. Carbon is 12.0 grams per mole, hydrogen 1.01 grams per mole. We know that there's one carbon. We find that number from the we find that number from the formula. And we know that there are 4 hydrogens. This number comes from the formula. So we know the mass of carbon, we know how many there are. Multiply these two together. The total mass of the carbon, 12.0 grams per mole. For the hydrogen, 1.01 times 4, that's 4.04 grams per mole. Last step, now that we know the totals, we're going to add them together. And so looking at our significant figures again, you see that carbon has a decimal and then 1 digit, hydrogen has a decimal and then 2 digits. So we can only go 1 digit after the decimal place. So here's my decimal point. And the 4 does not round up, and so it's going to be 0.0. 12 plus 4, 16. And that's grams per mole. So let's look at another one. Let's look at CO2, carbon dioxide. And we're going to use this system to find the molar mass of this compound. So here's the table, molar mass, quantity, and total. So in this compound, we have carbon, we have oxygen. The molar mass of carbon, we find it on the periodic table. To 3 significant figures, 12.0. The formula tells me that I have 1 carbon, which makes the total mass of carbons 12.0 grams per mole. For oxygen, the periodic table gives us the molar mass. Rounding says 16.0. The formula tells us there are 2 of them. And so this is 32.0 grams per mole. Totaling these up, 44.0. With units, it is grams per mole. Let's draw some lines here. So, like I said, this table method is kind of like training wheels. It's really helpful while you're learning, but then after you've learned, it just gets in the way. So, before I go too much further, I'll show you the method that I use now that I've got the hang of this. So I don't do the table except for when I'm teaching. So the way I would do this, and I'll write it up here. So I'd say I'm looking for the molar mass of CO2. And so I look at the periodic table. I'm working with carbon here. And so I say 12.0, and there is one of them. And so I go straight to my calculator. I put parentheses, 12.0 times 1. That is going to be this. And then I say plus, and I look at my next element. Here's oxygen at 16.0. There's 2 of them. And that's it for the compound. So I hit enter on my calculator, and it tells me 44.0. I give it units grams per mole, and this is a much faster method. It'll probably take you 25% of the time or less to use this method over the table. Here we have a slightly more complicated compound, calcium hydroxide. We're going to go ahead and get our table set up. So the first thing, we have calcium. Second element we have is oxygen. Third element is hydrogen. Looking at the molar masses, I get them from the periodic table. Calcium is 40.1 with 3 significant figures. Oxygen, 16.0 grams per mole. Hydrogen, 1.01 grams per mole. Quantities come from the formula. So quantity of calcium, you'll notice that there's no subscript behind calcium. That means there's 1. For the number of oxygens, here's oxygen. And looking at it, it doesn't have a subscript, but it's in a polyatomic ion. It's in parentheses. So this 2 goes to the oxygen. It tells me that there are 2 oxygens in there. This 2 also tells me that I have 2 hydrogens. We can go ahead and total these up. 40.1, 16 times 2 is 32.0, 1.01 times 2, 2.02 grams per mole. So we're going to go ahead and total these up, and we'll round to the end. So nothing here, there's a 2, this is a 1, this is a 4, 74.12, and that's 3 grams per mole. Remember our significant figures rule though. These two numbers only have one digit after the decimal, which means that our answer can only have one digit after the decimal, which means it's actually going to be 74.1 grams per mole. To show you the same sort of quicker method for this one, here's what I would do, and I'll draw this one in, let's say purple. So I would say that calcium hydroxide, I know that calcium's molar mass is 40.1, and there's one of them, plus oxygen is 16.0, and there are two of them. Hydrogen is 1.01, and we have 2 hydrogens. And so I put this in my calculator, and I get 74.12, which we then round .1 grams per mole. So this is the training wheels method, the good way to learn it method, and this is the fast, get straight to your number method.